Presentation. We are the Defense Systems Information Analysis Center, or DSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. DSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the defense systems community. As such, our organization supports those working in the defense systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the defense systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD defense systems research.
Hello, everyone. Welcome to our webinar. My name is Taylor Knight. I am with DSIAC. I'm the Technical Inquiry Research Lead. Thank you for joining us today. We're really excited to have Mr. Bill Beglin with us for our webinar. Before we get started, I do have some quick housekeeping notes. If you're on the WebEx platform, we'll be using a Q&A versus the chat. So anytime during this webinar, if you have any questions, if you can click the 3 ellipses in the bottom right corner, you can enter a question at any time. At the end of the webinar, we will go through it, I'll moderate it, we'll ask as many questions as possible, and Mr. Beglin will answer them. Also, if you experience any technical difficulties, this is being recorded, so you'll be able to view it later at your convenience. Today, we are lucky to have Mr. Bill Beglin. He is a graduate of Virginia Tech, and he currently holds the position of Principal Research Engineer, Program Manager, and Team Lead at the University of Dayton Research Institute. He's currently contracted to the Air Force Research Laboratory's Vehicle Integration Group based at Wright-Patterson Air Force Base in Dayton, Ohio. And in this capacity, he oversees programs and ensures the fulfillment of contract deliverables with major airframers, as well as various small business initiatives. Drawing from his extensive experience, Mr. Beglin has been instrumental in multiple exploratory air vehicle design programs, covering areas such as tactical tankers, alternative aircraft launch and recovery concepts, and uncrewed air vehicles, including collaborative combat aircraft and long-range ISR platforms. His proficiency extends to utilizing Command Professional Edition software for effectiveness analysis of air vehicle systems during the initial stages of program development. Also, prior to assuming his current role, Mr. Beglin held senior executive positions within notable US-based corporations. So with that, I'm going to hand it over to Mr. Bill Beglin. He's going to be going through this webinar with you. And again, if you have any questions throughout, please go ahead and enter it in the Q&A, and we'll go ahead and get started.
Thank you, Taylor. I'm going to pull this up and see if I can get it to share correctly. I think there we go. Soon we can see that. Title this, Effectiveness of Metric Matters. I want to thank everyone for joining in today. Hopefully this will provide you with some information that is beneficial to your endeavors. One of the things that we've looked at when you think about effectiveness is that you have all these different partners or parts of your aircraft, weapons, propulsion systems, sensors, avionics, and so on. And there's a tendency many times just to develop very exquisite components. And that's fine. But what really matters is, how are all these put together? How do these various technologies come together to really provide you the effect that you're looking for? And unfortunately, many times that effectiveness is only looked at later stages in the program when you've gone down the road a ways, selecting weapons or sensors or so forth, and then you find out that maybe you're not getting the effect that you want, or maybe you have a bit of overkill, spent too much, and so on. So as we go forward, I want to talk about a couple of different things. One is just component design by itself, and then there's composite analysis. We typically develop very exquisite components, sensors, weapons, and so forth, great technologies, and many times these can be expensive and have very, very long maturation curves. That's probably fine when you're developing the latest fifth, sixth generation aircraft. But in today's environment, where particularly when we're looking at smaller uncrewed aircraft, this composite design, or as I like to call it, the what if analysis, really becomes much more critical, and particularly critical in the early stages. So to do this, one of the things that you have to start with is, what's the challenge or the mission that you're trying to run? What scenario do you want to use to look at this effectiveness of whatever platform it is you're developing? You have to start out by developing performance metrics. What measures of effectiveness are you really trying to achieve? Once you've determined those and start to run your analysis, you can get a pretty good idea of what those measures of performance are that give you the effect that you want. And that encompasses all the various pieces. Sensors, how much range do they have to have? What kind of resolution at range? How much power do they consume? With weapons, you're looking at, again, what kind of range do you need? What's the probability of kill? How big are they? They fit in your aircraft. How much do they weigh? What kind of guidance system do they have? The aircraft itself, what kind of range do you need? Kind of signature does it have to have, particularly if you're going into a highly contested environment? How much payload can it carry? Does it need to carry? And again, what kind of power can you provide? And of course, propulsion. I always laugh sometimes when people talk about rubber engines. There is no such thing as a rubber engine. You generally have to pick from a relatively select group. But again, you get back to thrust, fuel consumption, how much power output do they have, much weight, and so forth. So when you get right down to it, modeling and simulation analysis across a range of component combinations, not just individual, just not selecting a component, but a range of those combinations. This gives you that what if analysis. And this helps determine what's the most effective combination of these various components at a macro level, at the early stages. It's not at the highly detailed level that you have later in a program, but this initial front end. So one of the tools that we've used is a program called Command, and Command PE mean Professional Edition. One of the benefits of this program is that it really occupies a useful middle ground between, tabletop exercises, scrums, and so forth, and much more detailed traditional engineering models, which can give you very finite details, but may take days, months, and longer to develop before you can actually get actionable information out of them. So let's talk a little bit about what this program Command PE can do for you, and particularly in what we're discussing today, effectiveness analysis. First off, it's multi-level, multi-domain, constructive simulation, and the key point here is supports rapid iteration. You can put scenarios and mission analysis together in a very short period of time, a matter of literally hours and days, not weeks and months. One of the key pieces of this is the database that comes with it that supports over 100,000 systems of systems, going back all the way to World War II, up through the present and into the future a bit. And we'll talk a bit more in a minute about what is included in that database. It gives you rapid worldwide scenario development. So literally the entire world is built into the system in very detailed maps, anything just a latitude, longitude grid on up to very detailed terrain, so that you can, again, not have to build this from scratch. Program is algorithm-based physics models for both sensors and propulsion parameters. And one of the other key attributes of this is the stochastic modeling. for sensors and weapons, so that when you're running, after you've set up your scenario and have your mission set up and have it operating the way you'd like, now you can do Monte Carlo runs with literally a couple mouse clicks. And this variability that's built into the model provides you with a range of outcomes of that scenario after you've run your Monte Carlo analysis. Very powerful capability. Obviously, high fidelity combat interactions and data output. Data output we'll talk a bit more in a minute. And in case you're wondering, it's utilized by some 150 or so defense organizations across 23 different nations. So there is a broad user base, and obviously that user base has a lot of influence over the further developments and enhancements that are made to the program. Let's talk about the database for a minute. As I mentioned, over 100,000 inputs, and on the left you can see the main components that are in the database. Aircraft and facilities are things like radar units, SAM units, structures and so forth, ground units as you would expect, tanks, trucks, and weapon systems, howitzers and so forth, and of course ships, submarines, and satellites. And then the subsequent blocks, the primary and sub blocks, are all the components and parts that feed those main set of components. On the right is this is from pretty much last fall. I'm sure these numbers are actually larger now, as Matrix updates this database generally at least a couple of times a year with new additions or maybe improved data on existing systems in there. As you can see, pretty endless number of items to draw from. And one of the key points of this, particularly of the professional editions, all of these can be modified. And I'll show you an example of that in a minute. But the benefit of that is you don't have to start from scratch. If you want to develop an aircraft that's reasonably similar to another aircraft that exists, or maybe it's an uncrewed aircraft or a drone, you can simply pull that up, clone it, and then make whatever modifications you want to it. This saves a tremendous amount of time, particularly because of the fact that if you're talking about an aircraft, you're not just talking about that aircraft, you're talking about having to put sensors on it and weapons and propulsion and so on. And all of those can be pulled from existing, or as I said, modified and placed into a new vehicle. Because early in the program development, you don't want to spend a lot of time finding and vetting and inputting a lot of data. It's much easier, much quicker to utilize something that already exists, and it can be easily cloned and modified. As an example, and this is probably a little bit difficult to read unless you're looking at it on a large screen, but let's take an F-15EX. These are the basic inputs that are already in there, just pulled up in the database. And while I don't want to try to go through everything that's in here because we have limitations of time, I'll talk about some of the major pieces. There's a very top section are the basic size, weight, climb rates, ranges, etc. for the aircraft. And then you go into this signature box, and I'll come back to that in a minute. Sensor capabilities, what are the sensors on board? And then, of course, mounts and loadouts and communication. So let me pull up a following slide here, and you can see a bit more detail. So, as I mentioned, these are stock and customizable inputs to all the components that are part of an aircraft. So let's start on the left where you see the signature block. So you have visual, infrared, and radar, and DBSM for the radar. The way this works is that if there are known values for these, those are put in by Matrix and vetted. If in fact you're developing, let's say, your own aircraft, and you've put in its physical dimensions, the program will auto-calculate these inputs for it. And those can be modified, as you see, by these signature modifiers below for both visual, IR, and radar. Now, those are things like buried inputs, shielded exhaust? Does it have structural shaping to lower signature? Does it have radar absorbing materials? I think there's in a range of about 40 different modifiers. If you want, you can even make them invisible. But again, the benefit of this is you can tailor these inputs to the analysis that you want to run. And many times what you want to do is make variations in these inputs and see what impact that has on the effectiveness of your platform. Sensors. This is a sensor suite that's on an F-15EX. Again, all of these sensors you can pull up within the database. You can add them to another aircraft. You can modify their capabilities. You could in fact go in and drop some of these out of an F-15 and say, okay, how effective is it without a certain capability? This is one of the great strengths of the program. Let's go down to loadouts. Again, when you're running mission analysis, you don't want to have to stop every time that you're maybe looking at a different target set and having to go in and load a different weapons loadout. I believe on the F-15, there's something like 30 different loadouts that are already built into it. There's a scroll bar, so you can just run down through here and pick the specific loadout that you want to analyze for a mission. And again, if you're developing a new platform, you can do the same thing. You can build in, one loadout, you can build in 20 loadouts. So that way, when you're analyzing and in the early stages of a program and want to understand the benefits of different weapons or different sensors or different amounts of weapons and so on, very easy to build those into this database and then utilize them within your missions. So there's also on there's a noodle loop, traditional, set up so that you can take and vary how long it takes to, spot something, take an action, decide and act. Communications, whatever you want to build in communications, link 16 on up. The propulsion, there's a large number of engines already in the program. You can use those and then tailor that particular engine to the specific platform you're on so that you can set fuel consumptions and cruise speeds at different altitudes. You control climb rates, agility. I'm going to talk a second about agility. The way agility works in the program is that the aircraft are ranked on a comparative basis. So for example, something like a B-52 might have an agility of, say 1, whereas an F-22 would have agility, say 5.5 or 6, and so on. So while it's not that detailed, degrees per second, those algorithms are built into the program in the background. But from the standpoint of development, it's much easier to allow you to put in an agility factor. And then if you want to vary that, do you want the aircraft to be able to maneuver, be highly maneuverable, implying, higher G loads, which starts to test the structural integrity that you build into it? Or do you want it just to be something that cruises at the high altitude, is not particularly agile, but has quite a bit of range for doing ISR missions? Takeoff and landing distances are built in, and there's similar inputs for the 19 other components and subblocks. Obviously, there are different parameters, but the benefit of this is you can go in to a radar, for example, and change the PRF, or you can look at resolution and power consumption and so forth. Again, very, very easy to do within the system. Okay. So one of the things that's not directly in the database, but built into the program are air bases. And I believe this is Eglin down in Florida. The benefit of this is there's not every air base in the world, but there are air bases in virtually every country in the world and a large number of them. The benefit of this is if you're running a scenario and you want to attack specific targets on an air base, fuel storage, for example, maybe just the runway, ammunition storage, each of these blue icons that you see here, when you pull it up in the program, will be identified as to what it is. And these are very accurately placed within the program. So again, if you're targeting an airbase and you want to just pick out specific targets for your weapon system, very easy to do. You highlight them and then add them to the target list. Um, Again, one of those things that's very useful. The other thing you can do is if there's an airbase not exactly in the location you want, you can create an airbase and you can move these around and put them where you like to have them. The program will put them right where they're supposed to be, but you have the flexibility to move them from there. So, um, excuse me, mission modeling capabilities. So, okay, you have this great database. Um, and let's see what you can now accomplish with it. Multiple sides. So you can do blue, red, you can do your own allies, you can do neutral sides, which may put into some commercial airliners flying around in an area that you don't want to target. And these can all be designated as friendly or unfriendly or hostile. And that, of course, has an impact on the action that each side takes. You can set scenario durations anywhere from minutes to hours to days, and start them at any hour, day or night. Um, Multiple missions. Now, this is something that have always been in there in the front end, meaning things like strike missions, patrol missions, support missions like a tanker sitting off, burning holes in the skies waiting to refuel aircraft, cargo missions, and of course ferry missions between operating bases. And of course, with that, you can set takeoff times. What's new and extremely beneficial is time on target. If you've ever done any modeling and tried to coordinate your attack, say, let's just go back to the airbase example, and you want to bring in assets, whether they're from a ship or from another operating base, this time on target capability is a huge benefit. As you know, if you don't have that capability, you tend to have to run the program several times, adjust your takeoff times, etc., so that all your assets arrive when you want them to. With this capability, as you can see that the little red arrow points at it says weapon target, you can set a time for that weapon to land on that target. And the system will back calculate all the steps to make that happen. Takeoff time, when their turning point, when the weapon time is launched. In this case, you probably may or not be able to read that, but it's about a 20-minute time from the time the weapon's launched to it reaches a target. The benefit of this is once you've set this up, and in the lower right, you can see a rough example. By the way, that white line going across is a satellite pass. I should have taken that out. But you see these waypoints. You can go in and drag those waypoints and move them around. And you can also go to each waypoint and set an altitude and speed that you want the aircraft to be at when they leave that waypoint. The benefit of this time on target capability is that when you do that and move those waypoints around or change the altitude and speed and so forth, the program automatically adjusts the takeoff time to account for that. You could also do something like put in an air refueling location. And again, the program will adjust for that. This is a relatively recent addition, sometime last year. Huge benefit when you're setting up missions, and particularly if it's a more complex mission with a number of different assets. And as I said, you can adjust that flight plan, waypoints, and altitude and speed. Lewis scripting and trigger for events to initiate specific actions. I'm going to come back to that on the next slide because that's something that's well worth taking some time to understand. But capability within mission modeling, again, drones and loitering munitions. We're paying much attention to Ukraine, I think, as everybody is. Obviously, drones have made a major impact. So things like the Bayraktar drone, the Shaheds, the TB2, the Switchblades, they're all in the database already. So you can just select those and put them into your mission scenario. And again, they can be modified and changed to suit your purposes. Area-specific weather. This is one of the things that previously had been just sort of, mission wide or scenario wide. Now you can go in and create areas by selecting, reference points, defining that as an area, and setting weather for that specific area. So, for example, if you're going across the coast where the weather might be nice and clear and into a mountainous region, you may want to recognize that a little bit cloudier, maybe there's some storms and rain and so forth. Obviously, those are going to impact your sensors, your weapons, and so forth. So that's a nice addition. And again, it's one of those things that allows you to build some variability into your analysis. Communications jamming and intermittent emissions. Communication and radar jamming, I should have added that to that, is obviously a capability you can build into an aircraft. You can send in something like an EA-18G Growler and just use it. By the same token, you could create your own small aircraft and pull some of the components that a Growler might carry and use them. And the benefit of that is obviously, again, running up against various IADs with different capabilities and seeing where the best effectiveness is. Intermittent emissions, one of the things that's recognized is that when you go up against certain IADs, they're not just sitting there with all their radar lit up all the time. You can now go in and have those come on at a routine frequency, come on randomly, come on when they're attacked or detected. So this adds, again, another level of realism to your scenario. Cargo capabilities. Cargo has always been in the program, but there's been a lot of enhancements to us over the last year or so. So I guess the analysis comments that you hear many times is that amateurs talk tactics, professionals talk logistics. So, for example, if you have an operating base and you're sending aircraft out of it, you can set it up where they have unlimited weapon stores, or unlimited magazines. To put realism in, you obviously would want to limit that to what is on the base. And then if you want, you can set up supply routes from anywhere from CONUS to other operating bases to main operating bases or forward. You can ship them via air, ship, truck, rail. So a lot of flexibility that I have not used this a lot, but my understanding is that it's been a tremendous add for people that really are looking at the logistics side of deployments. And I mentioned tailorable data export. So you can essentially, after when you set up a mission, you can decide, well, what is it that I want to get out of it from a data standpoint? Do I just want to see where aircraft were when they're engaged, latitude, longitude, range, altitude? Maybe I want to see sensors and I want to see when they couldn't detect something, when they failed, or when they actually did detect something, and then following that, when they ID'd it, because there's obviously a difference between when you can see something on radar or with a sensor and when you actually know what it is. Same with weapons. How many weapons were fired? When were they fired? What impact did they have? How close to the target did they get? And particularly when you start looking at things like hypersonic weapons. Very good at avoiding being targeted because of their speed, but then you have the issue of accuracy. So you can again go in and there's an AGM 183, I believe, already built into the database. And you can go in if you want and modify its circular probability of, impact so that you can put some realism into there and in the ways that you see fit. Fuel burn, both by aircraft or ship or tank or whatever, as well as fuel transferred. So if you're doing performing aerial refueling, you can track that as well. And then of course, location, where all these assets located, and damage. Is something 10% damage, 50%? Is it destroyed? Very beneficial to use. One of the other things, and I probably I think I don't know if I mentioned it previously or not on the database, is that while this is an unclassified database, all of the data in it has been vetted per matrix by at least 3 sources, and they continually look for improvements or updates in data to make sure that database stays up to date. The other real benefit is that if you want to run in classified environments, you can do that with the program, and then you can put in whatever data you'd like. And the last thing that I missed to mention is going back to radar. One of the things that you can do is if you have a detailed radar splat, something that you might normally plug into a program like AppSim, you can now enter that into Command PE so that you have a very accurate signature profile for an aircraft. Again, most likely something you would do at a higher classification level, but capability that is there nonetheless. Let's go on to talk about an event editor. Now, an event editor is basically a series of capabilities that are linked together. So let's just start in the upper left. And this event is, I'm going to assign a northeast radar and a ground launched cruise missile, a TBM, as targets for B-52s. That's the event. Now, I'm going to have a trigger that ties into that, okay? And what that trigger is in this case is in this block right here, and that is SAM northeast is 50% damage. So I've got this northeast installation with some various assets, but I've got a SAM protecting it. So I don't want to send in other weapons to try and destroy those until I've taken out that SAM. So once I've got that SAM 50% damaged, or 60 or 20 or whatever percent you want, that's going to create a trigger that's going to initiate this action. And there's two actions in this action block. The one is assigning a B-52 to a strike mission. I've had B-52s in this case just loitering out at a distance, and now that I've identified a target and I've destroyed the SAM that's protecting these targets, I'm going to assign these two B-52s into a B-52 strike mission, okay, via these Lewis scripts. The second action I'm going to take is I'm going to assign that GLICM, radar, and TBM as targets. So I've placed the B-52 into a strike mission, and I've given it these three targets to go after, to fire their weapons at, in this case, cruise missiles. The benefit of the whole ability to set up these in the event editor is that it's almost limitless what you can do with it, and provides that capability so that within a mission and in a scenario that you're running, given the fact that there's variability built in, when certain things happen in a different scenario run during a Monte Carlo analysis, things are going to happen at different time frames, and sometimes they're not going to happen. You can use these events to say, well, if in fact this happens, then I want you to take this action. A target's destroyed, so now I want to assign my assets to another target. An aircraft, one of my aircraft destroyed, now I'm going to send in a replacement for it. So it gives you a tremendous amount of ability to build, I guess, new steps into your scenario, so that as you do your Monte Carlo runs, you get this flexibility that is really important to be getting a really full analysis of the effectiveness of the assets that you're utilizing. So some examples, excuse me. Air-to-air and air-to-ground versus adversary aircraft or ships or fixed or mobile surface targets can be run. Aircraft teaming with obviously the advent of crewed and more uncrewed aircraft that are going to come into existence over the coming years. Maybe set up ratios of how many uncrewed aircraft do I want to send in with my 4th and 5th gen versus their 4th and 5th or 6th gen, and even set up an adversary's uncrewed aircraft. So those kind of capabilities are in there. Cross-domain coordination, obviously I can launch aircraft from a base or ships or some other means. And I can select and develop and utilize existing and hypothetical weapons sensors, engine, electronic countermeasures. Again, for effectiveness in an early stage of analysis, you want to be able to look at a number of variations to understand where the benefit really lies. And you can develop effectiveness ratios. How many red aircraft versus blue aircraft were lost? How many weapons did I have to fire to take out an adversary, and so on. And then, of course, you can do cost comparisons. You can build in costs to your analysis. And lastly, skill and awareness capability levels. This is a kind of a slick little ad that's in the program. As a campaign goes on, the skill level of some of the pilots on your adversary may be going down. So you can vary that. And you can do the same thing with the quote awareness levels of, say, their IADs, excuse me, assets. So again, those are the kind of things you can run. On the upper right, you can see some aircraft coming in, two waves of aircraft versus a very complex IADs along the coast. So let's go on to maybe a more direct example. ISR and strike analysis example. Let's pretend that we have in the mountains of California, Nevada over here, we have some red vehicles. We've got some SAMs, some long-range radar, some ground-launched cruise missiles, and tactical ballistic missiles and communications capabilities. I want to send in an ISR aircraft launch long range into this search area, and I want to send these in so I've got pretty much 24-hour coverage over it, because these mobile targets can be moving around and I want to know where they're at. I can fly the aircraft in on a fixed or random pattern within that AOR until they either reach bingo fuel and have to go to a forward operating base to refuel, or in many cases they're destroyed. The idea is to send these in to ID these mobile targets, and not just detect them, but actually ID the type of target they are and communicate that to bomber aircraft with long-range weapons. In that case, you can see sort of loitering up here at a distance. And we decide in this case, well, let's use some hypersonic weapons. We don't really have them yet, but if we had them, they'd be kind of nice to use to launch against SAMs. And then once the SAMs are neutralized, now I can fire cruise missiles, JASM, long-range JASMs in at these other targets now that I've taken the threat of the SAMs out. So just a quick example of the kind of things, and you can set this kind of scenario up in a couple of days and have it up and operational, and then do your Monte Carlo analysis and see where the benefits are. Okay, so wrapping up, let's talk about a sort of a what-if analysis opportunities. Hope you've picked up that you can do these in the air, littoral. You can do just basically land engagements. You can do base or high-value asset protect. You can do suppression and defeat of enemy air defenses. And if you notice the pictures, that one in the middle, B-21 Raider, and if you want to know, yes, it's already in the database. So if you want to utilize it, it's in there, and you can change the parameters in it in terms of what it can carry and how fast and far it can fly and all those things to your heart's content. Again, the benefit of you don't have to start from scratch. In the upper right, an unmanned drone aircraft, maybe supersonic unmanned drone aircraft that you could build in. In the lower right, Rapid Dragon, fairly new capability. Essentially allows cargo planes to be weapons platforms. What can you do with those? What else could you do with Rapid Dragon? What could you combine it with? Combine it with other jammers and decoys and combined assets. So the intent of this whole presentation is to have you think about what can be done early in a program, so that you look at and sort of maybe free up your imagination and try to think about, well, what is the biggest benefit I can give to the warfighter? What things maybe haven't we thought about yet, and what capabilities, if we had them, would give us a very strategic advantage. So last couple of slides, some recent enhancements, and I have that note there, some in a beta test. My put this together last fall and had some delays to be able to present it that were my fault. So a lot of these things that were in beta tests are now part of the standard program. Some that we've touched on: time on target capability and mission pooling and flight plan editor. We've covered enhanced flight formation, and crewed and uncrewed, so that I can actually pick the type of formation, diamond formation, straight line formation. And I can set spacing between the aircraft. Touched on custom environment zones and intermittent missions. WRA, weapons release authorization, and the no escape zone. What the weapons release authorization allows you to do is to determine how many aircraft do I want to use to engage other aircraft or ground targets. How many weapons do I want to use against various targets? What type of weapons range do I want to fire those weapons? Do I want to fire them at max range? Do I want to fire them at 50% of max range, so I only fire when the target's in the no escape zone? The next one, limited aircraft and crew endurance. This is kind of interesting because in the past, you could essentially have an aircraft flying for forever and just keep refueling it. What's built into it now is an auto return to base that you can tailor, but obviously crews only have a certain amount of endurance, which again is one of the benefits of uncrewed aircraft. So these next couple items: infrared and visual sensors, tailor radar scan angle limits, and the phased array off boresight gain reductions, all have been improvements to the program and the algorithms that are in it. I will be the first to admit I am not by any means any kind of a sensor or radar expert. They speak a different language. But all of these improvements have greatly increased the realism and the accuracy of the results that you get. Daisy-chained data links and communications. Loitering weapons are in there. And this next one is kind of interesting. You can now set this up, and this is to be a great training aid. 16-person gaming with a real-time battle manager, so that you could have teams set up with a battle manager and have step through a process and allow the teams to make adjustments as that game progresses. Excuse me. And the last one, the double flame mode, I get kind of a kick out of. The way the program's set up is you can run it at standard speed, 1 times actual speed, 2 times, 5 times, 10 times, and then a flame mode. And flame mode basically will run as fast as your processor on your whatever computer you're running on will let it run. And when they went to 64-bit last year, they came up with a double flame mode. This is a huge benefit, particularly if you're flying aircraft in from, say, 1,000 miles away. You don't want to sit there and just watch it sort of creep in over time. You can get it there very quickly and then go in and slow down the scenario while it's running and you're visualizing it, and be able to watch in detail as a battle unfolds. So next slide, and I need to read this disclaimer that the content or appearance of the commercial Command Professional Edition software does not reflect an official DoD or Air Force Research Lab position or endorsement of the external information, products, or services contained therein. The views expressed are those of the authors and do not reflect the official guidance or position of the United States government, the Department of Defense, the United States Air Force, or the United States Space Force. So with that, I'm done, and we'll turn things back over to Taylor to do moderation.
Great. Thank you so much, Bill. We have a handful of questions, and I'm just going to dive right in so we can try to answer as many as possible before kind of 1 o'clock end time. So I'm going to start with, what is the classification of Command PE, and does this run on a laptop?
It is unclassified, and I run it on an MSI laptop. I would recommend you get the best, fastest processor, and importantly, a graphics card that can keep up with it.
The next question. How is this extensive database V&VD? Have these platforms or sensors been vetted with actual vendor and prime data, or just published open sources?
It's both. It's primarily Matrix indicates that they try to have three independent sources. It is an unclassified database. I will tell you that people that understand and know a lot of the classified information will say it's pretty damn accurate. And again, the benefit of being able to modify the database is that you can go in if you have higher level information, you can take the program into your vault, into your classified location, and input that data into the database so that you have that higher level of accuracy.
Next question, who owns the model and what does it cost to use?
A company called Matrix owns it. I don't want to quote their exact prices, but a couple of things. One is they have a commercial version that you can buy for your home computer for in the range of like $70. And I would send you directly to Matrix. And Taylor, if you can post that email address for
I
Matrix.
did. I actually sent it to the chat already.
Yeah, if you put that in the chat,
Mhm.
that's your best contact because there's some different pricing for, I work for a university, so there's a little bit different costing. And yeah, Jason Jones and then the people at Matrix will be more than happy to help you with that understanding of cost.
Does the model account for transport or tanker shortages?
Say that again, transport.
Transport or tanker shortages.
You can build that into it if you want to do transport. So for example, you can set up a base out on Guam and just put whatever aircraft you want there. You could also have no aircraft there and fly them in as part of your scenario. And the same thing goes with things like how much fuel is on the base? Is there enough fuel that I can refuel tankers? Because I can send a tanker out, for example, let's say I want to have tankers out in an area for 2 days, and I want them out flying orbits. So as those tankers give fuel and hit their limits, they go back to the base. There's a turnaround time that's built into the program for them to be refueled and turned. And again, that's something you can modify if you want, and then they will go back out. So that way you can build some realism into your ability to say have tankers out in a refueling orbit. I hope that answers the question.
How does one acquire this tool? Oh, sorry, we already answered this question about, I'm gonna breeze through some of these that are asking about costs and licensing. Next one. Does this simulation suite support the delivery of nuclear gravity bombs or cruise missiles?
Yes, you can put nuclear bombs in it. And that's again built into the program. It's on items like B-52s and B-1Bs. That's one of the loadouts that's built in. And you can set the, again, in the MCON for different missions, you can set that up where no, you can't use any nuclear weapons or you can. And then you can also start to designate things like I will only fire if I'm fired upon, or target's hostile. As soon as I see him, I'm going to shoot. So you have a lot of capability in that area. But to your nuclear question, yes, you can.
Can you speak to the model's capability to incorporate cost data and or generate costs for specific scenarios?
It's really not, that is not part of the program. If you're going to build in cost, you would take the results that come out in the data dump and do your own cost analysis. So that is not part of Command PE.
Are you able to model CBurn weapon effects in the software? And if not, can Command PE interface with any existing CBurn M&S software?
You're going to have to ask that one of Matrix. I'm not, I know that if you're talking about, I don't use it a lot for anything in the ocean, in the sea. I know things like when you put in weather effects over the ocean, As the wind builds and the waves get higher, that slows down how fast your ships can move. So that type of thing is in there. But beyond that, I would say let's ask Matrix directly.
How does Command PE compare to AFSIM or NGTS?
It comes up a lot. AFSIM is, if you're familiar with it, is very detailed. And, people will argue that, you can get more accurate results. They're really two different animals. Command PE is set up, as I mentioned, to do this sort of, I don't want to say a quick look analysis because it's more than that, but it's set up so that you can very quickly do your analysis. And in many ways, I would say that the benefit of Command PE is that it allows you to go through a large number of variations, excuse me. Look where the big benefits are and where they aren't, and then maybe take some of that and go into something like AFSIM at a more detailed level where you can build in much more detailed, say, radar analysis, maybe more detailed aircraft metrics and so on. So it's think of Command PE as a great front end. And again, this is why we use it on the early stages of program analysis, because you can run through a lot of different variations very quickly and get through that initial analysis of what makes the most sense and where to start to spend your money and where to do more detailed analysis in a case where you might want to then go to AFSIM. Over.
Does this simulator simulate EO sensors to test ML-based classifiers?
Yes. And again, if you have a specific question, in more detail, I would go directly to Matrix on that. They are the experts.
Question is, what meteorological data is supported in the simulation? Are historical weather stored for use?
Basically rain, cloud cover, and wind are the primary ones.
Are there any plans to have a Linux port of this software?
Say that again, I'm sorry.
Are there any plans to have a Linux port of the software? I might be saying it incorrectly, Linux.
Yeah, I'm familiar with Linux. I don't know. Again, that's one for Matrix in terms of what their future developments for the program are going to be.
What does the customer support look like for this tool, and is there training available or a user manual?
Yeah, what we found is when you purchase the license for the program and you've downloaded and using it, they have a direct line to their experts, and I have found them to be very responsive to questions. It's one of the differences in the benefits of the professional edition. The commercial edition is, hundreds of thousands of users. Now, that's a real benefit in that you have a large user base that when you make changes and updates to the program, you have this huge commercial user base that is using as I said, the $70-some version. But the benefit when you pay the extra money for the professional version, its capability is you get a direct link to their support staff. And as I said, I've found to be very responsive and very helpful to the point of just being honest and saying, no, we don't do that. Yes, we're considering doing that. Or by the way, we just rolled this out and you should be seeing it soon and so forth. So you do have a direct access to them.
Okay. I'm just kind of scrolling through, trying to find some newer ones we haven't hit on yet. Is there an API that can be used to set up and run simulation or scenarios apart from the front end?
There is a command line interface if that's what you're asking. I don't know that I'm answering that, but there is a command line interface that you use if you're familiar with that kind of capability.
This one's a bit long. I'm gonna try to summarize it. Do you have any insight into combining effectiveness and performance data gathered from constructive or virtual sim tests with live tests to build a holistic assurance that the system will perform correctly.
In terms of, no, the work that we have done, we don't have that comparison of saying, here's what we predicted coming out of Command P, and we thought, so no, we don't have that direct comparison.
Do you have any idea if Command PE has been used for AI autonomous algorithm training?
I do not know that. There's, AI is such a broad subject. You can argue that there's parts of this program that have that in it, but I don't have any specific knowledge of that.
I'm going to end with one more question since we're about at our time limit. Last question will be, what is your insight into selecting effectiveness metrics for a mission and the analysis that should be conducted against your performance metrics?
I think it really gets down to when you set up a mission, and let's just stay with aircraft. There's some basics, right, that you want to get out. What's important is to get if you have an end customer, if you have someone that some group that can say, this is the effect we're trying to get, here's what we'd like to be able to do, that should help you set up your analysis and your measures of effectiveness. Because if they don't care how many weapons you use, fine. But if it's someone that says, I want to be able to attack this target from this range, and I want to be able to use this type of weapon, etc., that can start to build your case or build your scenario that you want to run. So my advice is always understand who it is you're serving and who it is you're doing this analysis for, and start up front and make sure you understand what it is that group wants to accomplish.
Great. Thank you so much, Bill. We're going to end the Q&A session there. So if we didn't get to answer your question, Bill, is it okay if we send out your email address for people to contact you for further discussion?
Sure, absolutely.
Great. I'll throw that in the chat for everyone. Also, I had a couple questions asking about availability of the slides. This was recorded and it will be put onto DSIAC's YouTube channel. So you will be able to view this at your convenience when it's posted. It usually takes about a week. And typically you will get an email, especially if you registered for this webinar, an email will be sent to you that you can access. If not, you can always go onto our YouTube channel and check and see when it is posted. But about a week usually it takes to get up there. Thank you so much, everyone, for joining us. Really, thank you so much to Bill. We really appreciate your expertise and your time with this webinar. I hope everyone has a great day, and we're going to go ahead and sign off from there. Thank you, Bill.
Thank you. Thanks all.